This is chapter 6, part 1, timber design. Introduction will be on the design deck. This figure from the industry I took from their website, the Sawmill of Malaysian Timber by the company named as Best Matrix Sdn Berhad. This is how they are loading and how they put the timber at their factory. Okay, this is the timber has been processed from the log, so this is how they look like and put under the roof as a dry process. And this is the last process how this timber can be used. So it can be used as a timber bedding and handrail as shown in this picture. This is another use of timber due as a function of a plywood. This is a 7 timber specification. Just can read through. Okay, and then no need to repeat it. Read through and try to understand each of these 7 specifications. And what is the species? This is some of the meanings of the species in timber, and they are involved in many choice or species that um, took from its structural view, and it's graded in based on its stresses, which is the prime important. And some species has a different characteristic in it, and it should be graded accordingly. And this is how to determine the specification of each of the timber grade. So if you can refer to the Malaysian Standard Part 2, they have many series of strength group, okay, which will be explained later on. And this can be found in table 3. Okay, table 3 has a lot of species which are grouped under strength categories. And also you can found in tables 1 and 2, and whatever type of timber, so it is recommended for construction to use a full sawn timber. This is the one example of the table group as a naturally durable type of timber, where have 5 groups. SG1, SG is a strength group, strength group 1, strength group 2 until strength group 5, and strength group 1 is the most durable, consists of balau types of timber, bitis, changal, and penaga. And you can see also the group for strength group 2, SG2, belian, mata ulat, kakatong. And you just can read through all of these timber names and in each group. And this is another group where this is require a treatment, where consists of 6 groups, starting from strength group 2 until strength group 7. Okay, you just can read through all these lists in each of the strength group. Okay. After the species, now we go to the grades. Okay, after the species, there should be grades. And it will give a different grades for same species, and this can be seen in Malaysian Standard also in part 2. And we can go to Appendix C, and this Appendix C based on the grading limit for Malaysian grading rules for some hardwood timber. How to group this based on the grade stress. Okay, grade stress, there are 2 conditions. The first one is wet, and the second one is dry. And you can found in the Malaysian Standard at tables 1 and 2. There are 2 individual, which is the hardwood and softwood species for this table 1 and 2, and table 4 is the group as a strength group, SG, and grades. Okay. Okay, this is only the condition if it's dry and that specifically dry. So it is minimum thickness is 75 mm. You just can read through this sentence. Okay, now this is the table. Okay, the table consists of weight, grade, stresses of timber. Okay, this is all the types of timber and all the value for bending parallel to grain, the tension parallel to grain, compression parallel to grain, and compression perpendicular to grain. Okay, perpendicular is like this, parallel is like this. Okay, this is parallel, parallel, and parallel, and shear parallel to the grain. And each of these timber has a minimum, mean and minimum of modulus of elasticity. SEL is the select, STD is standard, and COM is common. So all these are value based on each type of timber. Whether you want to design based on the select, so if this is the value, or based on the standard, this is the value, and common, okay, this is the value. So all these value are given accordingly with the type of timber. Okay, same for this table, but this is only for dry grade stress. Okay, this is the type of timber and the value in each of the um, select, standard, and common. And then in table 4, they group into two wet and dry grade stresses for various strength of group. And this is if it's under category strength group of SG1, so the condition either wet or dry. So this is all the value given. And each of these given the value for SG1 and SG2 for all of the condition, sorry, the various strength group of timber. Okay, this is only to determine the dimension and the geometrical properties. Okay, you just can go to table B3 and B4 at appendix B, and also we have a common commercial timber given in table B1. The limit and permissible deviation can be seen in table B2, and okay, for timber specified according to appendix B, and it is should be based on its minimum size. So there's no need for domination. You just go through the tables and see the size from there. Okay, this is only the theoretical of what is the full zone and bare zone. You just read through. This is the geometrical property of sawn timber at wet condition. For example, we have a size nominal 25 times 25 mm. Okay, where the minimum requirement for this size is 22 times 22 mm, and the area for this size is 625, and all the parameters for each of these values. Okay, same as if you want to design for the steel, you need to refer the table. So this is the table for timber. And this is for table of dress sawn timber. Okay, the same, similar, but only the types is different. Okay, this what is called grade and the strength ratio to the strength properties. For example, SEL is a select structure. The bending and tension parallel to grain and also compression parallel to grain is 80% strength, and compression perpendicular is about 85%, and shear parallel to grain is 72%. For standard structural, it's 63, and 80 and 56. Okay, so we can see that the select, standard, and also the common has given a different percentage of strength ratio to the strength properties. This is based on the study. I don't know the name of the author, but this is what they found from that study. Alright, this is the theoretical. Please understand and read again and again. Okay, what is the, this is actually the repetitive from what I explained earlier. Okay, there are four types of group strength that we can consider. For example, if it's under group A, so it is considered as extremely strong. Group B is a very strong. Group C is strong, and D is weakest. Okay, the strength group previous slide. So we check that the group A and B here is given the strength group from the Malaysian standard. For example, column beam barrier stud joist. So this is under strength group A and B. So if it's from the Malaysian standard, it can be seen it is for group SG1, SG2 until SG4. And you can see from formwork and roofing, the staircase flooring, just you can refer to this table and how they relate the group A, B, and C and D to the strength group 1 until 7. And this is the application, the continuation from previous slide. Okay, for this is for wall and ceiling frames as well as door and window frames. And for furniture also we have the group strength of timber. Okay, and this is based on these two study by Engku in 1988 and the latest one of Malaysian Standard 544 Part 2. That's all for the introduction of timber. So we'll see you the next lecture on the design of flexure timber. Thank you guys. Bye. Moisture content, the strength of the wood is influenced by the moisture in it. Under saturated fiber, wood strength increases with decreasing moisture content. On top of saturated fiber, the strength of the wood remains unchanged. Thus advisable to benefit from influence of this moisture content by issuing stresses to two surface conditions, either dry or wet condition. Based on the moisture content of the timber installed in various parts of country, so this is the outer Engku has set the aspiration line for humidity and dryness at 19% moisture content. For timber that are 100 mm thick or more, wet conditions should always be used because this hardwood is difficult to dry. The dry exposure is all service condition where the air temperature and humidity will result in solid timber attaining an equilibrium moisture content not exceeding 90% for any significant period, and this exposure includes small covered buildings and internal use. Wet exposure is all service condition either in contact with water or where the air temperature and humidity will result in solid timber attaining an equilibrium moisture content exceeding 19%. And the permissible stress should be obtained for the wet exposure condition by multiplying the dry stresses by appropriate modification factors, and such stresses